Welcome to WIPL-D ProCAD 2013 video tutorial. The first step in the EM simulation of complex CAD geometries is the import of a CAD file. Various formats from IGES to CATIA are supported. The next step is repairing the geometry, which includes omitting a lot of unnecessary mechanical details and repairing imperfections using healing tools. After that, the file is meshed. And the last step is EM simulation. So, let's start. The first step in the process is import. WIPL-D ProCAD enables import of various commonly used CAD formats. Even a basic inspection of geometry indicates a highly complex model. Total number of entities is displayed in the info window. The model consists of 28 bodies, 23 regions, and 1,344 faces. We aim to calculate the monostatic RCS of the aircraft, and only geometrical entities belonging to the outer metallic shell are required for such a simulation. The original geometry comprises of many more details, like the interior of the cockpit. After selecting and hiding bodies which form the outer shell, the remaining interior bodies are shown in the preview. Now it is easy to select all the obsolete elements and delete them. All bodies except 3 are regularly closed bodies. Their respective icons in the model tree indicate this. Also, the subtree shows these 3 bodies to not contain any region. The reason why the bodies are not closed is the irregular connection of certain faces. After inspecting the bodies of 2 rockets and fuselage, it is obvious that they should also be closed. Thus, invoke the healing tool named Sew Faces. The process consists of selecting all faces that belong to one unclosed body and applying the feature to them. This operation enables bodies which were not closed to become regularly closed bodies which possess the interior region. After the healing process, all bodies comprising the model should be united into a single body. The process is simple. It consists of selection of all bodies and performing the Boolean operation unite. After the union, a number of interior faces remains. The presence of these faces can be illustrated if we remove the preview of half of the model located in the negative y coordinate. That leaves half of the model displayed. All interior faces have the incorrect domain specification M00. They represent metallic faces inside of metallic regions. Feature name validate recognizes such faces and offers their automatic deletion. The model is geometrically symmetrical. In order to reduce the number of unknown coefficients and simulation time, it is enough to simulate only half of the model. This is provided by using the feature named Crop by Plane. As the final step in the process, we define symmetry in the Y plane. Before meshing the structure, simulation settings should be adjusted. The first step is to set the operation mode of the simulation to RCS monostatic. Simulation frequency is 2 GHz, which yields 100 wavelengths as the electrical length of the aircraft. Next, we define the incoming waves symmetrical to the aircraft symmetry plane, which is the Y plane in this case. Last, we define the number of directions for incident waves to 721. Now we'll proceed to the meshing stage. The meshing algorithm, even with default parameters, results in an excellent mesh. The total number of mesh elements, which are quads for WIPL-D, is 12,420. The number of plates on certain parts of the aircraft is too large and the mesh elements are too detailed. An equally good mesh can be obtained with less elements. For this case, we are not setting any local mesh parameters. We are increasing mesh parameters named angle tolerance and defeature tolerance. This results in a mesh that excels both in precise geometrical modeling as well as in a low number of elements. New number of elements is 7,541. In addition, WIPL-D ProCAD 2013 allows export of geometry into various CAD formats. Thank you for your attention. For further information, please visit our website.